Hi friends, I'll start with the next finding envelope of family of curves with the two parameters. So if two parameters will be given, then two curves must be given there to get the envelope here. So here the procedure, two families, family of curves B, f of xy with the two parameters a, b is equal to 0, and another equation will be given, only the relation between a and b will be given. So using these two equations, you have to find the envelope of family of the curves here. So procedure for these, just you have to differentiate equation 1 and 2. That is equation 1 and 2 with respect to the parameter, that is a, keeping the b as a function of a and x and y as a constants. Then by differentiating these two equations, first one if you differentiate with respect to, that is b, you are getting it is a function of x, y, ab and bb by dx. Second one is just a function of ab and bb by dA. So by using equation 4, get the value of dB by dA, substitute in equation 3. And you have to get the next by using other procedure, you have to get the required envelope. So you come to know by using the example. So let us start with the example. Find the envelope of curve x square by a square plus y square b square is equal to 1 if a and b are rated by a plus b is equal to c. So this is already, you know, the curve ellipse. So these are all the family of the ellipses, so that sum of the major and minor axis will be constant. Means suppose constant c is 16, then a and b may be 115, 214, 315, that is the 312, like that. Sum should be equal to 16 here, 313, 412, in that way. Go on changing the major and minor axis and drawing the ellipses. You are getting at the end one envelope here, that you have to find it. So let us take first envelope of family of curves. We have to consider first the given family as x square by a square plus y square b square is equal to 1 here. And a plus b is equal to c, we take it is 2. Then differentiate the first one with respect to the b, sorry, with respect to a, we can get x square is a constant, differentiation of a square is minus 2 by a cube, and y square is constant, differentiation of 1 by b square is minus 2 by b cube into db by dx, and right hand side is 0. Then you have to simplify. Similarly, you have to differentiate 2 with respect to, that is a, differentiation of a is 1 plus differentiation of b is db by dA, and that is equal to 0. Therefore, this dc by dA is equal to, bring this one this side, minus 1. And this dB by dA minus 1 you have to substitute in equation 3. You can get x square into minus 2 by a cube plus y square into minus 2 by b cube minus 1 is equal to 0 here. So this is very important step after this. Then simplify this equation. So it is minus of 2 and minus of 2 throughout will be cancelled. Just remaining is minus, sorry, 2 and 2 will be cancelled. Minus of x square upon a cube, and here minus this minus becomes plus y square upon b cube is equal to 0 here. Then how you have to get remove of A and B. So here afterwards the procedure is little different. So it is just to get x square upon a cube is equal to y square upon b cube here. The same procedure you have to apply for all the examples. So how to adjust this x square by a cube is equal to y square by b cube? What I will do now, under this a cube I will take one a. So just remaining x square upon a square, and that a I will write like this. So totally it is nothing but x square upon a cube itself. So it is x square by a square divided by a is equal to, here that is equal to has not come, and it is y square upon b square is equal to, similarly 1b you bring it here, e is equal to. So here a by c, b is equal to c by d. In real properties of real numbers, I think you studied one property called componendo and dividendo. That means if a by b is equal to c by d, then a plus, that is c, is equal to divided by b plus d. There is a componendo dividendo. If you, these ratios are always equal to, that is the sum of the numerators divided by sum of the denominators. So it is x square upon a square plus y square upon b square divided by a plus b here. So this is equal to this, and these two are equal to this. But here x square by a square plus y square b square is equal to 1, that is given equation 1, and divided by a plus b is given as, that is c. So I have to write 1 by c here. So now this ratio is equal to 1 by c, and this ratio is also equal to 1 by c. Therefore, you can write x square upon a cube is equal to 1 by c, y square upon b cube is equal to 1 by c here. So it is just a cube is equal to cx square plus b cube is equal to cy square. Then a becomes cx square raised to 1 upon 3, b is cy square raised to 1 upon 3. Substitute these two values in equation 2. You are getting cx square raised to 1 upon 3 plus cy square raised to 1 upon 3, that is equal to c itself. So that is nothing but cx square means c raised to 1 by 3 into x raised to 2 by 3 plus c raised to 1 by 3 y raised to 2 by 3 equal to c, and c raised to 1 by 3 you bring this side, it becomes 2 by 3. So it is x raised to 2 by 3 plus y raised to 2 by 3 equal to c raised to 2 by 3, which is the required envelope, and that is asteroid already. You come to know that it already you know this equation. Thus you can say that envelope of family of ellipses under the condition a plus b is equal to c. That means go on drawing the ellipses with the sum of the major and minor axis will be constant. Then you can get that as a asteroid. So geometrically you can see that in the next video I will show it. It's here. Go on drawing the ellipse. So here this is the ellipse where this is A and this is B, that is equal to constant C. With the same constant C, go on drawing the different A and B's. With different A and B's, but the sum should be same. Like that, you go on drawing the ellipses. And collection of these ellipses itself is the family of curve with A and B as a parameter. So in this way, if you go on drawing, yes, at the end you can get, see this curve you are getting. So this curve is just like a asteroid. So here at the end you can get this is an asteroid. So this is asteroid. I hope all of you can see the figure in the form of asteroid. So family of these, envelope of the family of the ellipses with the condition A plus B is equal to C is always, it is asteroid. Similarly, if we put the different conditions, you are getting different curves. So next example, same type, find the envelope of family of line cities. So you have to take the line x by a, y by b equal to 1. You know already this is the intercept form of the line. So that again here, sum of these intersections be equal to c. Here also if you take a is equal to c, suppose you fix as 20 here, then a may be 1, b may be 19, a may be 2, b may be 18, a may be 3, b may be 17, like that. Go on changing these a and b values, but this should be remain same. With respect to that, go on drawing the line. You are getting the intersection of all the points of the lines, you are getting one angle. That you have to find it geometrically also and algebraically. Now you can prove it algebraically. Given families x by a, y by b equal to 1, so that a and b are connected by a plus b equal to c. So differentiate one partially with respect to, actually differentiate one with respect to a itself. It is not partially you are getting with respect to a here, treating x and y constant. So x into differentiation of 1 by a minus 1 by a square, y into differentiation of 1 by b minus 1 by b square into dt by dA, differentiation of 1 is 0. Get the value of dt by dA from this. It is dv by dA is minus 1. Substitute that in equation, that is 3. In equation 3, you can substitute and you can get x into minus 1 by a square plus y into minus 1 by b square into minus 1 is equal to 0. So simplify, it is x minus 1 by a square minus minus it becomes plus y by y into 1 by b square equal to 1. That is, you write this side, so it becomes x by a square equal to y by b square. So after this, whatever the equation of the equation 1 will be there, according to that you have to adjust. So 1a you keep it here, 1a you bring it to the denominator. So x by a divided by a, y by b divided by b, this you have adjusted. Then by using component and dividend of method, so adding numerator, adding denominator, the ratio is same. So x by a plus y by b divided by a plus b here. But x by a plus y by b is 1 by using equation 1. A plus b is equal to c by using equation c. Sorry, equation 2. So it is 1 by c here. So that will be, again this is nothing but x by a square. So I can write x by a square is equal to 1 by c and y by b square is equal to 1 by c here. Therefore it is a square is equal to c into x, b square is equal to c into y, a is equal to root cx, b is equal to root cy. Substitute these equations, these two in equation 2. It becomes root cx plus root cy is equal to c itself. Or it is root x plus root y is equal to root c. So that will be the required answer. So this is, so if you draw geometrically, that is, go on drawing the lines so that this is A and this is B, so that it is be fixed. A plus B is equal to some constant. So again this is A and this is B. As A increases, B decreases here. Like that, go on drawing the lines. So again here this is A and this is B. Then again this is A and this is B. So in this way, A plus B must be fixed. So but go on changing A and B here. So like that, if you draw the lines, you are getting at the end one curve here. So this is the curve. So this curve you are getting, and that curve will be root x plus root y is equal to root c. This is the envelope of family of lines x by a plus y by b is equal to 1 if a plus b is equal to c here. Next, similarly, for the same family of curves ellipses, but here the second equation is product is c. A into b is equal to c here. So in that case, so envelope of family of curve x square by a square plus y square b square is equal to 1. Take it is equation 1. A into b equal to c as 2. Then as similar to previous example, differentiate 1 with respect to, that is a. Then we can get x square minus 2 by a cube, y square minus 2 by b cube into db by dA is equal to 0. Same as the first example, let it be 3. Then equation, this 2 you have to differentiate, that is a product rule you have to apply, db by dA plus b into definition of a is 1, definition of c is 0. Therefore db by dA is equal to minus b by a here. So this value is substitute in equation 3. You can get x square minus 2 by a cube plus y square into minus 2 by b cube into minus b by a here. So that is nothing but minus 2x square upon a cube plus minus into minus plus, that is 2 into by square upon a b cube is equal to 0. That is x square upon a cube, and it is b upon b into y square upon a b cube. 2 will be cancelled here. Next, 2x square by a cube is equal to b into y square upon b cube. So a will be get cancelled, x square upon a square. B will be get cancelled, y square upon b square you are getting. It is x square upon a square by 1 is equal to y square upon b square upon 1. So here you have to write this as in the form of equation 1. So x square by a square itself is there, so you have to write x square upon a square. Suppose if it is a cube, 1a you have to bring the denominator, but here it is a square itself. Usually in the product, you are getting denominators as constants. Therefore, again by using componendo and dividendo method, sum of these two divide by sum of the denominator. So it is x square upon a square plus y square upon b square divide by 1 plus 1, 2. So numerator is 1 by using equation 1. Denominator just constant, it is 2. Therefore now x square upon a square is equal to 1 by 2 you have to write. Y square upon b square is also equal to 1 by 2. And get the value of a square is 2x square, b square, 2y square. Therefore a is equal to 2x square raised to half, b is equal to 2y square raised to half. So substitute the values of a and b in equation 2. You can get 2x square raised to 1 by 2, 2y square raised to 1 by 2 is equal to c. That is nothing but 2xy equal to c square. So this is actually the rectangular hyperbola, and this is the required envelope of the family of curves. So this is algebraic method, and geometrically here you go on drawing the lines with the product is C, means suppose C is equal to, if I take 16, then A may be 1, B may be 16, A may be 2, B may be 8, A may be 4, B may be 4, and like that. A may be minus 1, B may be minus 16, and A may be minus 2, B may be minus 8. So you can get the curve in the third quadrant, first quadrant as well as the third quadrant, both positive and both negative here. So you are getting here it is the upper and this is the lower edge. So this is the envelope of the family of the curve x by a plus y by b is equal to 1 with the product AB is given as C. So usually in such examples, you are having the either the product or the addition. Similarly, you can try the examples of the same. So you can try this example. Find the envelope of family of curves x square by a square plus y square b square is equal to 1 if a square plus b square is equal to c. So I hope you can do it. Suppose if you don't get it, please call me. So this completes the chapter that is the envelope, and I hope you followed both how to get the envelope of family of curves with one parameter and two parameters. So thank you. And it is already told that the next week we are going to engage the test on paper 1 with the two chapters. One is polar coordinates, another is unit 3. So I hope you can prepare it